Hello everyone, this is Venkat. Welcome to Venkat's Tech Talk. This is the sixth part of software design pattern presentation. In last five parts, we looked at what is design pattern, value of design pattern, design principles, solid principles, and couple of examples on the design patterns implementation in .NET framework, patterns like observer pattern, iterator pattern, and other few other patterns. So now it's time to look at few more design patterns. In this presentation, we are going to look at factory pattern and strategy pattern, and we are going to look at what are all those patterns and how it's implemented in .NET Base Class Library. And also we are going to look at some of the deeper techniques or source code within .NET Framework to see how it is written, certain things you are written using these patterns. Okay, let us straight away jump into the topic. So factory pattern, let us look into factory pattern. So what is factory pattern? So basically factory pattern helps to deal with problems related to object creation. It moves the responsibility of object creation into a separate class called factory. Factory encapsulates the logic for object creation and returns the created object. Okay, straightforward. So we all know that one of the key principles in design is single responsibility principle. So we want to make sure every object has a single responsibility, and also we want to ensure that no objects are tightly coupled. So we don't want to introduce the dependency. These are all uh, some of the important key principles in designing a software. So one of the key thing is we want to eliminate the dependency within the classes. Basically, if we want to use an object of another class, we don't want to create that object within a class. So if we go ahead with creating an objects in each classes as a for dependency, then we are introducing a tight coupling between these objects. And tomorrow, if you want to change the implementation, it will be very difficult. So um, so we want to avoid that. So common practice to avoid creating objects are using factory pattern or using DI, dependency inversion, dependency injection containers like ninject, autofac, unity, those kind of containers. So using DI containers are kind of very bit rich in features, like you can manage the life cycle of the object creation and you can deal a lot of things with that one. A simple way to implement this is using a factory pattern. So as the name suggests, factory is nothing but which produces something. Factory produces something. So in software context, a factory pattern is something that is takes care of responsibility of creating an requested object and returns the requested object. It creates and gives the requested object. So that is called factory. This is a factory class or a factory method is a class and method responsible for creating the object and giving it to the caller. Okay. So this is very abstract in nature, whatever I explained. So it would be very clear if we look at an example. Is there an example in a .NET base class library? Yes, we have. So if you ever come across system.net.web request class, this is one of the factory class and it provides a method called create, which is a factory method. So basically, in a network programming, we deal with multiple network resources like HTTP resource, FTP resource, and file system resource, and those things. So we may need a specific object to deal with a specific type of resource. So, so the type of object that we want to deal with comes from this factory. Like if you want to create an object, instead of creating the dependency within a class, we call a factory method, which is a create method on a web request, which is part of system.net.web request. And if we call the create method, this create method acts as a factory and it returns either an HTTP web request or FTP web request or a file web request object as a result. Then we can use that specific object and do whatever we want to do. For example, if you want to deal with an HTTP resource, we can go ahead and make a call and do whatever we want with that object. Okay, how it works, how this factory method works. So basically, how it decides like what object it want to return, and if you see, all of them are inherited from system.net.web request. So just it returns the type of system.net.web request, but the implementation of any of these types it will be returning. So when we call a create method based on the resource we supply, for example HTTP URL or an FTP URL, based on that system.net.web request constructs the required object for this particular requested resource, and it provides back the object to the caller. So basically for this request it returns HTTP web request. So this is not very tricky pattern. It's a very straightforward pattern, easy to understand. I don't think any complexity in this pattern. Just a factory pattern takes care of object creation responsibility, and it creates the object and it sends back. So it is also called as a poor man's DI, dependency inversion, because it's very straightforward to implement. You don't need any third-party container or anything to import your logic. Just you can write your own class, move all the logic of object creation within that class. So tomorrow, if an implementation we want to change for an HTTP, we want to send some different object, just change this factory and make the appropriate changes. So this is factory pattern. Okay, not a complex pattern. That's it. Let us go with another pattern available in the .NET base class library. This is strategy pattern. For me, I consider this an interesting pattern, and also there is at least something there for this pattern where we can learn something very interesting. So strategy, so the name suggests it is a pattern that allows an end user or a caller of an API to inject the custom logic into a method, and yeah, just inject a custom logic into a method. Means like, wait, I will show an example, it will make it clear. So strategy pattern is a behavioral pattern that allows to select an algorithm at runtime. Means like we'll be able to provide an algorithm or inject an logic into a function as a parameter. Generally what we do, we send data as an argument to a function. So here it is a bit different. We are going to send an algorithm or a logic as an argument into a function. That means we are injecting a strategy. A strategy here is an algorithm or a logic that we want to perform. So that is the usage of this pattern. So it will be very clear if we look at an example. So if you look at the list class in .NET base class library, it heavily uses this pattern. Hope you have come across with these methods like link methods like find all, where, and find first, find last, and many other find related methods. So basically what it does, if you are familiar with list class, this works on any type of list object, a generic type. And for example, if you have a list collection, a list object dot find all, and you can pass an expression what you want to find. For example, assume if this list is having an integer items, a list of integer numbers, I want to find all the odd numbers. So here I can pass the expression to filter the odd numbers. So like object of t lambda expression where t divided by 2 equal to 0, something like that. We can express our logic here at this place, in this place of predicate, and then this find all method will use this injected strategy or injected logic to filter what we request for, and it gives the filtered list. Okay, so this is an excellent example of understanding the strategy pattern. So if we want to implement anything where we want to provide an end user to inject a logic, inject a strategy, then this strategy pattern can be used. An ideal example is all the link method in C# list implementation. Okay, so see here, integer list, we have list of integer, and int list dot find all. So we want to get all the even numbers, so which is 2 4 6 8 10. So this will be our expression to filter the request, the even numbers. So it takes an integer as an parameter. So basically, and it evaluates this condition if it is divided by 2, and if there is a remainder of 0, then we want to filter those number. So basically it will check each number and apply this logic, and if it matches this condition, and those collection of numbers will be returned. Okay, so even numbers 2 4 6 8 10 will be returned for this expression, and just if we join it and print it, it's going to print this one. Okay, so this is how the implementation looks like. So here if we look at bit technically, what is this? This is a predicate. What is predicate? Predicate is nothing but an delegate. Delegate is an something, a pointer to a function. If you look at, this is a delegate predicate which takes one argument and returns a boolean value as a return type. So basically this is the input argument, and this evaluation I divided by 2 equal to 0, which evaluates to a true or false, is the return value. This is a shorthand expression. So predicate is a delegate, we are using it here. So through a delegate we are trying to inject our custom logic to get the things done, and we are getting the value. So this is a strategy pattern. So this is another example of another method, find lost. We want to get all the we want to get the numbers greater than 3, but the last one, so which is going to fetch the 7 from this list. Okay, so this is an example. So as I already mentioned, let us go one step further deep to understand how this find all is implemented. It looks like magic, right? We are giving this value and we are getting the filtered array. So now with all the .NET Framework code is available as an open source, we have the privilege of looking into the real implementation of even this method to see like what exactly happening within this method. So let us go one step further to look like how this is implemented. List of t.findAll, and this predicate is implemented. So this is our our code logic, and let us look like what is the source code of find all looks like. So this is available in the reference source.microsoft.com. This is the bookmark page where you can go and look at complete .NET Framework source code. You can find all the methods and all the parameter implementation to see like how it is implemented, all the functions. So I would highly recommend, if you want to know a quality coding, or you want to understand how a complex logic are expressed in a very validated code base, where tested validated code base, this is the place where you can go and look into. So because not only you will learn the design pattern, you will learn a best code, like how they have written, for example, take an example like we use order by function. Order by, in a link, takes the complete list and it orders, sorts, and gives the result. So sorting is one of the complex topic in the designing or software engineering, because to sort a list of numbers or a list of string, there are various technical approaches, like bubble sort, quick sort, various other tens and tens of different sorts. So what kind of sort .NET Framework is using? If you do an order by, how it is working, how the classes are designed to do an order by. So all these things, now since this source code is open source, we can go ahead and look into it to see like how it works. And to talk about that particular concept of how ordering works, it altogether deserves another video completely, because it uses multiple sorting mechanism based on the type that we want to sort. So basically it is using a quick sort. So this is an exercise if you want to deep dive into some of the advanced things, how it is implemented within the framework. So you can take a look. But for now, let us look at how the find all is implemented here. Okay, so as I already mentioned, this is the source code function of the find all, which takes a predicate. As I already mentioned, predicate is nothing but a delegate. That's it. It takes an one argument and returns a boolean value. That's it. So it predicate of this type, and then it just checks user passes some valid predicate, self-explanatory, and these are some C sharp this API library specific thing. Let us look at the core meat of this this function. So basically what it does, so it holds this value, this list of integer values internally in this array, underscore items array, which is a private variable within the class. I have not got all the complete source code for this list implementation, but if you look at the source code, you will understand this underscore items is the private variable where this collection is stored. And similarly, underscore size is the variable which holds the what is the size of this array, because internally it is stored in an array object, C sharp array, just a plain array object. So it uses a separate size variable to indicate what is the current size, because it has some blank values in the array as well. So for that reason, you cannot rely on the size of length of this array to find its size, because it will have few more additional extra blank elements to dynamically add or remove values. So size is the value. So using the size as an iterator, it iterates each element, takes the element of from the array, and it calls this predicate. Already we know delegate is nothing but a function pointer. So we are giving a reference to a function as a delegate, so it means like we can call this match method. So exactly that happens, match of these items of value. So as we know, this is going to evaluate. See, this is the evaluation. This evaluation returns a boolean value, I divided by 2 equal to 0. If it evaluates true or false, this match will return that value. If true means like if our expression is true, or if, in other words, if it is an even number, then it adds this value to this list. So it iterates and adds all the values to this list, and finally it returns the filtered list that comes out of this find all method as a return type, and we get into this value filtered array. Okay, really cool, right? This is one interesting thing that we try to learn by looking at the .NET Framework source code. So this is the deep implementation of strategy pattern. Okay, also this is to introduce a taste of how you can go ahead and look into the .NET base class framework source code to understand some of the implementation. So you have a lot of things within the framework to look at. For example, GUID. So see, it's a very interesting thing, because universally you will find only one GUID. It cannot duplicate. If you call a GUID.new, it's going to create one unique ID. So if you're too curious to know like how that ID works, you can go and look into that class to see like how that works. And similarly, lot of classes, hash table, dictionary, list, many things. Your curiosity can be answered by looking into all these source code implementation. Okay, so this is strategy pattern. Okay, so with this strategy pattern, I think all the key design patterns implemented within .NET base class library we have covered so far. So just a recap, so design pattern will fall into three categories of three types or category of design pattern: creational, behavioral, and structural. So creational pattern deals with creating and instantiating objects. Behavioral pattern focuses on communication between objects, and structural deals with the relationship. So if you look at the total number of patterns, there are 23 design patterns, and if you are interested in knowing about all these patterns or some kind of a master reference material to understand all these design pattern, there is a book called Design Pattern: Element of Reusable Object Oriented Software, which is by Gang of Four. So four authors written, and this is one of the very official book on the design pattern. So it has everything about it. One maybe a bit dry subject if you want to understand all the patterns. Not sure how much it will be useful to know everything. So but yeah, that's the one of the book. Okay, and my other recommendation is dependency injection in .NET book. This is not particularly focuses on design pattern, but this book talks about very key things in designing an application, architecting, um, and also design patterns, software design principles, and many key design related concepts in this book. So I found this book as one of the useful, very useful book. Author is Mark Seaman, and I really like this material, and I felt that I learned a lot from this material. So this is something which I would recommend if you are interested in to know more about these topics. Okay. um, Thanks for watching this entire video series. With this presentation is coming to end. Thanks for watching. uh, Stay tuned, I will add few more videos on various other topics to this channel. Thanks for watching. Have a great day. Bye.